Hi students, so let us move to the next concept of the class 12, that is nothing but the integral. So before going to the integral, so what we have came across till now, that is nothing but a differential calculus. So in differential calculus, what and all we have learned? We have learned the two concepts. One is derivative, another one is the differentiation. So differentiation and derivative. So what is derivative and what is differentiation? So clearly derivative, it is nothing but dy by dx. Differentiation is nothing but the process of finding the derivative. The process of finding the derivative is called as a differentiation, and derivative is nothing but dy by dx. It is nothing but a rate of change of y with respect to x. So this is nothing but a derivative. So geometrical interpretation, if I talk about a geometric interpretation of a differentiation or a derivative, means suppose if I consider a curve, say any curve, means if I take this one as a curve which is equal to y is equal to f of x, then if I talk about dy by dx, means the geometrical interpretation, what does it says? Dy by dx, it is nothing but a tangent of the curve. So dy by dx is nothing but, it means that the tangent of the curve. It also says the tangent of the curve is also dy by dx. It is nothing but a slope of the tangent of the given curve. So that is what a geometrical interpretation regarding the derivative it is saying. Suppose if I draw a tangent at this point, means the slope of this curve, slope of this tangent of gives us what? The derivative of the given curve. So this is what we have learnt in our differential calculus. Now I'll consider one of the situation. I'll consider a situation like, if I consider an interval, say from a to b. Suppose if I consider an interval from a to b. So this is an interval if I from a to b. So within this interval, the function f of x, what we have defined, it is differentiable. The function f of x is differentiable within this interval a comma b. So a function f of x is differentiable within the interval a comma b, means what does that implies? Within the interval a comma b, I can draw the tangent at any point of the curve. I can draw the tangent at this point, I can draw the tangent at this point. So at various points we are going to get a tangent. So clearly f of x is differentiable in a comma b, means it is clear that we know that f dash of x, we know the f dash of x within the interval a comma b. Within this interval we know all those tangents which are intersecting. Suppose if I consider like this, means so these are the tangents which are passing through the curve. So this is all these tangents at the different points within the interval a comma b, we are going to get the derivatives. So when we know the derivatives, that is when we know f dash of x of a given curve, means how we are finding the f of x. So how to get this given function, or how to get the function when we know the derivative of a given function. So when this situation came arise, at that time the concept called integration came to an into mind, or the concept integration has got an idea. Now suppose if I consider a function, say f of x, means, and if you need to get the derivative of that function f of x, it is nothing but f dash of x. To get the derivative of f of x, so from f of x I got f dash of x, which is nothing but a derivative. So the process of finding the derivative, is nothing but what? Differentiation. Right? This is what we have learned. So when we have the derivative of a given function and we need to find the f of x, so when they have given the differentiation and derivative and we need to find the given function, so this one, the given function, it is called as an integral. It is also called as an primitive. It is also called as an antiderivative. So it is called as various names. So when they are given the derivative of a given function and you need to find this function, and what we are calling this function, it is called as an integral or primitive or antiderivative. And the process of finding this antiderivative, is called as what? Integration. The process of finding this antiderivative is called as an integration. So clearly the integration, it is an reverse process of a differentiation. So clearly in the differentiation we know the function and we are going to take the derivative. In case of integration we know the derivative, we need to find the given function. So clearly integration is the inverse process. It is an inverse process of differentiation. So clearly the integral calculus, it is consisting of two type of integration. One is indefinite integral, another one is a definite integral. Okay, so in indefinite integral it is nothing but the process of finding an antiderivative of a given function. So when they are given a derivative and you are finding the antiderivative of a given function, means that is called as an indefinite integral. And when it comes to an definite integral, means if I consider any curve, say if this one is an x-axis and this one is y-axis, which is nothing but our f of x, means, so if this given curve is y is equal to f of x, means then the definite integrals, if this curve is defined within the interval a to b, means in definite integral we are going to learn the definite integral. What does this gives? Means area under the curve. It gives the area under the curve. So in definite integral, so the definite integral of this curve, that is y is equal to f of x, that gives us the area under that curve. So the area under that curve comes which? This curve. So how we are representing it? One, we are representing integral representation, we are representing it like this. So integration of f of x with respect to x dx, so a to b. So regarding the indefinite integral, we will learn in detail in the later section of this chapter itself. So up to 7.6 exercise we are learning upon the indefinite integral. After indefinite integral, later two sections we are going to learn about the indefinite integral. So in detail regarding the indefinite integral I will explain when we are talking about the indefinite integral. So please note down what and all I have explained in this section. So as I said, integration is the inverse process of differentiation. So let us understand how the integration is the inverse process of differentiation. Suppose if I consider, I will explain this one, the clear idea of integration by taking one of the examples. So if I take the differentiation, so if I consider the differentiation of sin x. So what is the differentiation of sin x? We all know that the differentiation of sin x is cos x. So as I said, the integration is the inverse process of the differentiation. So how we are considering the integration then? So integration, it is represented as in the differentiation we are representing it by d by dx. So if I need to find the integration of a cos x, means how we are dealing with it. So in here, the for differentiation we are having like this representation. For integration we have a representation of like this, and a extended version of alphabet. Yes, if we stretch this s, we are going to get in something in this manner. So this is an integration symbol. So d cos x differentiation, integration of cos x with respect to x, dx, it represents there is a variable, say x. So we are integrating the function with respect to the variable x. So integration of cos x, it is nothing but sin x. So clearly integration, what I said in the earlier section, if they have given the f dash of x, means we need to find the f of x. The process of finding the antiderivative of a given function is called as an integration. So here our f dash x was cos x. So we are integrating the cos x to get the antiderivative of cos x. It is nothing but a given function, that is sin x. So this is what the integration is saying. Now you can see here integration of cos x dx is equal to sin x. So clearly here the integration of cos x. So what does this symbolizes? Integration of cos x dx, what does that symbolizes? It is nothing but it symbolizes the integral of cos x with respect to x. That is what it is representing. And the cos x, what is there in the here? This cos x, it is called as an integrand. It is called as an integrand. And the x which is in the, if I consider the x here, so that x, it is nothing but what? It is nothing but an variable. The sin x which I have got here, the sin x, it is called as an integral. Sin x, it is an integral of cos x with respect to x. So this sin x is nothing but an integral of cos x with respect to x. So this is what a symbol integration, when we talk about the integration, means all these are one of the representations. So general, I will say it in the later section. So this is what this function we are calling it as an integrand, and after integration of an integrand, what we are going to get, it is called as an integral of an integrand with respect to an x, and this is a symbol which is used to represent an integration. Now you came to know that integration of cos x dx is sin x, where differentiation of sin x is cos x. Suppose now if I consider what is the differentiation of sin x plus 2, or what is the differentiation of sin x plus 4, or what is the differentiation of sin x plus 5. So clearly we know that differentiation of sin x is cos x, and differentiation of constant with respect to x, it is always 0. So again here differentiation of sin x is cos x, constant is 0. Again here it is also cos x. So in all these cases we got an differentiation of these functions, sin x plus 2 or sin x plus 4 or sin x plus 5. We got the differentiation or derivative as cos x only. But if I say the integration of cos x dx, means what you might write, you got here clearly integration is nothing but what? They have given the derivative and you need to find the actual function. So if I say the integration of cos x dx, means which one you might write? This cos x, it might be equal to either sin x, or it might be either equal to sin x plus 2, or it might be equal to sin x plus 4, or it might be equal to sin x plus 5. So we can't interpret it. So that's why the name the indefinite integral. So because we cannot interpret here what is integration of cos x to which value it is equal to when they are given some constant. So in that case we are writing it as integration of cos x dx is equal to sin x plus c. So where this c is called as what? It is called as an constant or it might be an any arbitrary value. I can say it has any arbitrary value. It might be equal to any one of this value. So when we say integration of cos x dx, when we talk about the integration means of any function or any integrand means integration of that one always equal to some f of x plus c, where this is always there in the integration, because we cannot interpret what is the value of c because it is an indefinite one. We can give the value, we can find what is the value of c when we talk about the definite interval. When in the later section of this integration only we will come to know how we are going to find the value of this constant c. Okay, so in up to here term, let us understand when we talk about any function means we are representing it with some function plus c. So we can say that in generals that c it is has an one of the parameter. So by varying this c, since I said it is an arbitrary values, by varying this value of c we are going to get different antiderivatives. So it is clear because you can see here itself, that is when c is equal to 2 we are going to get some other value, when c is equal to 4 we are going to get different antiderivative, when c is equal to 5 we are going to get different antiderivatives. So if the parameter c is varying means we are going to get different antiderivative. Suppose if I talking about the integration in general means the general representation, if I am talking means, suppose if f of x is a function, if f of x it is a function, capital F of x it is any function means, then differentiation of f of x we are going to get small f of x for all x which is belonging to the set of any given interval. If I consider any interval means for all x we are within that interval, this is differentiable. So here clearly f of x it is a given function and f of x it is a derivative of a given function f of x. So when we talk about the integration, so how it goes, so when we talk about the integration we are finding the antiderivative of a given function. So that is nothing but here we are considering the f of x with respect to the variable x. So it is equal to f of x plus c, where here this f of x it is called as an integrand, and this c it is a constant, it is some constant, and this x it is a variable, and this symbol represents we are doing the integration, and this process is called as an integration, and what the value we are going to get, this is called as an integral or an antiderivative or primitive. So this is what the general representation of differentiation and integration which is going to be symbolizes. So pause the video, understand the concept step by step, understand what the notation we are talking, which one we are calling it as an integrand, integral, constant, what is called as an integration. So all these things understand it properly and then continue the video. So the next, let us understand the geometrical interpretation of an indefinite integral. So we have came across what is that indefinite integral. So that is what the integrals we are going to get, integral plus c, such type of representation we are calling it as an indefinite integral, where we don't know what is that perfect value c is. So suppose if they are given the function, that is y which is equal to f of x is equal to 2x, and they are asking find the we need to find the integral, of this given function. That is nothing but we need to find different or integrate 2x with respect to the variable x, and we need to get the value of an integral. Say I will call it as an f of x. We need to get what is that value, even I too don't know. We need to get the value of that x plus c. This is what the this is what we are needed to find. So clearly we know that integration of f of x with respect to x gives us f of x plus c. Clearly f of x, that is small f of x. So if we know this f of x, through f of x, if we are finding this one, this f of x, this process is called as an derivative. And if through f of x, if we are finding this f of x, this is called as an antiderivative. So in other words, if I need to say this is an integrand and this is an integral, so clearly the differentiation, if we are differentiating this integral, means we are going to get the integrand. That is nothing but, if I differentiate this f of x, if I differentiate this f of x, what I am going to get? I am going to get this f of x. So this process is nothing but a differentiation, and the inverse process of this one is nothing but finding an antiderivative, that is this one. This process is nothing but as an integration. So this is what we have studied already, and I have expressed now this one in terms of two new words, that is integral and integrand. So understand the same concept with the two new words, that is integral and integrand. So clearly again now here I need to find this f of x. So through this general representation, what I said, the differentiation of this f of x, I am going to get this f of x, small f of x. So here 2x, it is small f of x, and we need to find this f of x. So this is our integrand and this is our integral. So clearly what? The differentiation of f of x, this f of x, we are going to get what? I am going to get this integral. So not integral, I am going to get an integrand which is equal to 2x. So clearly remember, to which function's differentiation I am going to get the what is the value of f of x, so that the differentiation of that f of x, I am going to get an value as equal to 2x. Suppose if I consider f of x is equal to 2x, then if I differentiate x square, f of x, not f of x is equal to x square means, and then if I differentiate x square means I am going to get 2x. So clearly here, if I differentiate x square, I am going to get the derivative of x square as 2x. So clearly the integration of 2x, so it is nothing but I am going to get the f of x as equal to what? The f of x is equal to x square. So clearly the integral of 2x dx is nothing but x square plus c. So now let us understand what is the geometrical interpretation of this indefinite integral. Suppose if I consider this the integral as y, which is equal to x square plus c, then I will try to plot the graph of this curve. Suppose if I call this one as x-axis and this one as y-axis, x, y, and this is x and this is y, which is equal to f of x. So this is what the our coordinate is. So clearly y is equal to x square, we know it is clearly a parabolic curve. Y is equal to x square, we already know it is a parabolic curve. So when c is equal to 0, the curve, it passes through the origin. So when c is equal to 0, the curve passes through the origin. So when I say c is equal to 1 means the curve passes through the point, say 1. You can check it. How you will going to check this one, whether how it is going to pass? When you take the value of x is equal to 0, value of y is equal to 1. So when you take x is equal to 2, so in that manner you can see here. So when I take c is equal to 2 means this curve passes through the point 2. So this is a curve, when this is a curve when c is equal to 0. This is the curve when c is equal to 1. This is the curve when c is equal to 2. Suppose if c is equal to -1 means the curve passes through -1 here. Sorry, you can get a clear curve. So when c is equal to -2, you are going to get this curve. So this is a curve when c is equal to -1. This is a curve when c is equal to -2. So here through this indefinite integral, what I said, the graphical representation or geometrical representation of an indefinite integral. So what we are going to get through the geometrical representation of integral curve, the geometrical representation of integral curve, indefinite integral, it gives us a family of curves. This is giving us the family of curve because the curve is only one, that is y is equal to x square. So we are going to get the family based upon this arbitrary constant. So as the c varies, we are going to get different curves. So we are going to get the family of curves through the indefinite integrals. So through this one, we came to understand what is the geometrical interpretation of indefinite integrals. So clearly here we have find out the integral of a given function through a inspection. We have through the inspection we came across how we are finding the integrals. So proper way of how we are finding the integrals we can see later. So this is what the geometrical interpretation of indefinite integral is going to be said. So now let us understand the clear concept of the antiderivatives and the integrals through some of the examples so that you can get a clear idea regarding about it. So first thing it is that write an antiderivative of cos 2x. So clearly antiderivative means what? It is nothing but we need to find the integral. Suppose if you are not getting what I am saying in terms of integral means, let us understand this one through the differentiation concept itself. So write an antiderivative of cos 2x means what does that implies? We need to find a function such that the differentiation of that function is equal to cos x. Suppose if I say the function say f of x means we need to find this function such that the differentiation of this function we are going to get as what? Cos 2x. So clearly the integration of cos 2x, we are going to get some function say f of x plus c. We need to find this function. So if we know the derivative of this function, we are going to get 2x. So through this function we are going to get cos 2x means it is called as differentiation. This is called as differentiation, and cos 2x, it is a derivative of f of x. Through cos 2x, if we are finding this f of x means this is called as an integration. This process is called as an integration, and through cos 2x we are finding f of x means this is called as what? This process is integration, and this f of x it is called as what? This is an antiderivative of cos 2x. So clearly now we need to find this f of x. So clearly we need to find the antiderivative of f of cos 2x means we need to find this f of x. So to get, there is no proper method how we are finding this antiderivatives and all. So differentiation, we know the differentiation, right? So clearly we know the differentiation of sine 2x. So what is the differentiation of sine 2x? So differentiation of sine, it is nothing but cos 2x. Chain rule, differentiation of 2x, it is 2. So clearly differentiation of sine 2x is cos 2x. So but what we required here, we required the what? Cos 2x only. So clearly in terms of differentiation I said, so we need to find this f of x so that the derivative of this function should be equal to cos 2x. So we got here cos 2x by 2, but what we required here cos 2x only. So to eliminate this 2, what we are doing, suppose if I take the derivative of 1 by 2 sine 2x. If I take the derivative of 1 by 2 sine 2x, what it happens? 1 by 2, it is a constant kept as it is. Derivative of sine 2x, it is cos 2x. Sorry guys, here it is sine 2x into 2. I have done it wrong. Sine 2x into differentiation of sine 2x is cos 2x into 2. So I need to get here what? Only cos 2x. This 2, it's not required for me. So what I do, if I take 1 by 2 sine 2x means 1 by 2 cos 2x into 2. So clearly now this 2 get cancels. What we got here? Cos 2x. So when we differentiate 1 by 2 sine 2x, we are going to get the derivative as cos 2x. So in terms of integrals, if I say, means what happens when I integrate cos 2x with respect to x, I am going to get an integral as 1 by 2 sine 2x. So clearly this 1 by 2 sine 2x is nothing but an antiderivative. It is nothing but an antiderivative of cos 2x. So this is what we needed to find. So there is no proper method. This is how we are generally going to find an antiderivative of a given function. So the clear difference, what is this antiderivative? What is this indefinite integral means? Clearly, if I indefinite integral. So indefinite integral, it is a broader meaning of the antiderivative. So if I talk about an antiderivative means we need to find a function such that the differentiation of this function gives us the integrand, or the integration of this integrand will give us this integral. So this is what called as an antiderivative is. Indefinite integral means what does that implies means there might be a certain function such that by adding that, if by the integration of that or the differentiation of that function, there are certain, so indefinite integral, what does that imply means there are certain functions, such that differentiation of those functions also gives us the derivative, cos 2x. So those certain functions whose derivative is also cos 2x, to overcome that one, we are adding that the integration of cos 2x dx, it is as by 1 by 2 sine 2x plus c. So this is a constant. So now the differentiation of these type of function, it might be any arbitrary constant, say c, this is an integral constant we are going to add. So it is a proper meaning. So indefinite integral, it is a proper explanation or a proper understanding of an antiderivative. So if we add this c means we are going to say a proper definition or a proper meaning of an antiderivative. So antiderivative of cos 2x is 1 by 2 sine 2x plus c. So this is how we are getting the antiderivative of any given function. Now let us move to the next thing, that is we need to find an antiderivative of 3x square plus 4x cube. So we need to find the antiderivative of this one means that what does that implies? There exists some function, say f of x, such that the derivative of f of x, it is what? 3x square plus 4x cube. So if I take the antiderivative of, we need to find an antiderivative, or if we take an antiderivative means we are going to get f of x plus c. In terms of proper meaning to give for an antiderivative means we are adding this integration constant. So clearly what does that is saying? So differentiation, if I differentiate f of x plus c means we are going to get what? 3x square plus 4x cube. Clearly since c is a constant, the derivative of that one, it becomes 0. So we need to find an f of x so that its derivative is equal to 3x square plus 4x cube. So through the differentiation what we have learned till now, we can clearly say that 3x square means what it will be our x cube, and 4x cube means the function it will be x to the power 4, because the derivative of x cube it is 3x square, derivative of x power 4 is 4x cube. So clearly what happened to our f of x? F of x is x cube plus x to the power 4. So the antiderivative of this function, so the antiderivative of the function, it is what? It is nothing but x cube plus x to the power 4 plus c. So if I write this one in the integration notation, means it will become integration of 3x square plus 4x cube dx, means integration of this one is equal to x cube plus x power 4 plus c. So this is how we are getting the antiderivative or any indefinite integral. So there will be no question in your examination like this we are going to find out. So I am just explaining how this process of finding an antiderivative and derivative, how those are connected, interconnected to each other, and how the process it goes. To understand that one, I am solving some of a random example to get the concept. The next is we need to find an antiderivative of 1 by x, means clearly we need to find a function f of x plus c such that the derivative of this function is 1 by x, and if we need to find an antiderivative of this function, we are going to get f of x plus c. So what does that implies? D by dx of f of x plus c, it is equal to 1 by x. So the differentiation of f of x is equal to 1 by x. So we need to find this f of x. What is this value of f of x? So clearly we know that the differentiation of log x, it is what? Differentiation of log x is 1 by x. Suppose if I consider the differentiation of log of minus x, means how it goes? It will goes with 1 divided by minus x, and the differentiation of minus x is minus 1. 1 get cancelled, so it is 1 by x. But you can, one idea might flash into your mind that when we are explaining regarding the log, the domain of the log was it is consisting of set of positive real numbers. But when I talk about minus x, means how it goes. So here clearly we don't know what is the value of x, whether x is greater than 0 or whether x is less than 0, we don't know. So this minus x, we don't know what properly it is. So either it is a positive or it might be a negative. We cannot get log is not defined for a set of negative real numbers. So when it is defined in the negative manner, so we need to, by combining these two, I can write it as d by dx of log of mod x, because when I write a modulus of x, means whatever the value might be, it might be a greater than or it might be a less than 0, the modulus x, it will make the value of log, I mean the domain of the log, it will be always retained with the set of positive real numbers only. So if I use d by dx of log of modulus x, it will be equal to 1 by x. So clearly the differentiation of log of modulus x is equal to 1 by x. So we got the derivative of log of modulus x is equal to 1 by x, means clearly our f of x will be what? It will be log of mod x. So clearly what happens? The derivative of log of mod x is equal to 1 by x, means the antiderivative of 1 by x is log of mod x. So if I mod x plus c, if I write it in the symbolical representation, means integration of 1 by x dx is equal to log of mod x plus c. So this is what the integration or the antiderivative or the integral of 1 by x, how we are going to get it. So now let us move to find the formulas, how we are finding the integrals. So this is very important. So the formulas for the integrals. So I am writing parallelly the derivatives as well as the integrals. So if I start with the finding the derivative of x power n plus 1 divided by n plus 1, where n is any some integer, means what happens, 1 divided by n plus 1. What is the formula of x to the power n plus 1 derivative? It is nothing but n plus 1 x to the power of n plus 1 minus 1. 1 minus 1 get cancels. So n plus 1 get cancelled. So the derivative of x to the power n plus 1 derivative divided by n plus 1 is x power n. So clearly the integration of x power n with respect to x power n dx means how we are going to find the integration of x power n. The integral is x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. When n is equal to minus 1, this becomes undefined. Suppose if they have given find the integration or find the integral of x cube, means how we are finding the integral of x cube dx. It is nothing but x to the power 3 plus 1 divided by 3 plus 1, which is plus c, which is equal to x to the power 4 divided by 4 plus c. So this is how we are using or how we are finding the integral of x power n dx. Now next, the differentiation of x with respect to x, it is always 1. So clearly if I am integrating 1 with respect to x, the integration of 1 with respect to x, it is always equal to x plus c. So this c, it is an integration constant. We are going to represent it for all the integrals. So similarly, the differentiation of any constant where c is some constant means differentiation of constant is equal to 0. So clearly the integration of 0 with respect to x, 0 with respect to x, it is always a constant, plus again constant plus constant is also a constant. So we are representing it with by just a c. That's all. So the next is, let us move to the different integration of an trigonometric function. So clearly we know that the differentiation of sin x is what? Cos x. So what does that implies now? The integration of cos x dx, the integration of cos is sin x plus c. So similarly the differentiation of cos x is what? Minus sin x. So suppose if I need the integration of only sin x dx, means what happens if I take the differentiation of minus cos x dx, means what is the differentiation of minus cos x? So differentiation of my cos x is minus sin x, and since it is there minus into minus, it becomes plus. So clearly the integration of sin x dx, it is what? It is minus cos x plus c. So in the beginning, understand with the simple thing, that is differentiation of cos is minus sin x. Since you need the integration of only sin x, means if I take minus cos x, means we are going to get sin x itself. So understand the relate in differentiation and integration through integral, integrand, derivatives, antiderivatives in that form which I have said earlier. So similarly the differentiation of tan x. What is the differentiation of tan x? It is tan x differentiation of tan x is secant square x. So the next is the integration of secant square x dx is what? It is tan x plus c. Similarly differentiation of cot x. Differentiation of cot x is minus cosecant square x. Suppose if I need the integration of only cosecant square x dx, means what we are doing? I am multiplying minus here, so that the differentiation of minus cot x is minus cosecant square x, and this minus into minus get plus. So what happens? Differentiation of minus cot x is plus cosecant square x. So the integration of cosecant square x dx, it becomes what? Minus cot x plus c. So similarly the differentiation of secant x, it is nothing but what? Secant x into tan x. So the integration of secant x into tan x dx. What is the integration of this one? It is nothing but secant x plus c. Similarly, the differentiation of cosecant x is minus cosecant x into cot x. Suppose if I need the integration of cosecant x into cot x dx, if I need the differentiation integration of this one, means I just multiply minus here, so that the differentiation of minus cosecant x becomes minus cosecant x into cot x into minus 1, so that minus into minus get plus. So this is equal to minus cosecant x plus c. So in general you can remember it in this manner also, so that the differentiation, that is the integrals of starting with the c, the integrals which we are going to get c has that thing, we are going to get minus here in the general way which we used to remember in our previous manner. So you can see the integration of some of the trigonometric functions like cos x, sin x, secant square x, cosecant square x, secant x into tan x, and integration of secant x into cot x. There you might miss some of the trigonometric functions like integration of secant x, integration of cosecant x, integration of tan x, and integration of cot x. So we will come to know the integration of all these things in the next part of the integration. So for up to now, let us understand the integration of these trigonometric functions only, that is cos x, sin x, secant square x, cosecant square x, secant x into tan x, and cosecant x into cot x. So these things you will come to understand in the substitution method. So it will be covered in the next section of this chapter itself. So the next is, let us understand the integrals of some of the inverse trigonometric functions. So we know that the differentiation of sine inverse of x, it is nothing but 1 divided by square root of 1 minus x square. So what happens when we talk about the integration? Integration of 1 divided by square root of 1 minus x square dx, it is equal to what? Sine inverse of x plus c. So the differentiation of cos inverse x is minus 1 divided by square root of 1 minus x square. So what happens here? This becomes, if I take minus cos inverse, differentiation of minus cos inverse x means it becomes again plus. So 1 divided by square root of 1 minus x square dx, it becomes what? Minus cos inverse of x plus c. Another, the tan inverse x is differentiation is 1 divided by 1 plus x square. So integration of 1 divided by 1 plus x square dx, it is equal to tan inverse of x plus c. Similarly, the differentiation of cot inverse is 1 minus 1 divided by 1 plus x square. If I multiply minus here, means it becomes plus 1. So it becomes 1 divided by 1 plus x square dx is equal to minus cot inverse of x plus c. And similarly, the secant inverse, the differentiation of secant inverse, it is equal to 1 divided by x into square root of x square minus 1. So the integration of 1 divided by x into square root of x square minus 1 dx, it is equal to secant inverse of x plus c. So minus 1 divided by differentiation of cosecant inverse is minus 1 divided by x into square root of x square minus 1. So if I multiply here, minus means differentiation of cosecant inverse is this one, and minus, since by the chain rule it becomes plus 1. So 1 divided by x into square root of x square minus 1 dx is equal to minus cosecant inverse x plus c. Now you can see here clearly that 1 divided by square root of 1 minus x square, for both sine inverse x and cos inverse x we are having the same. So generally we are using the integration of 1 divided by square root of 1 minus x square dx as sine inverse x, and here for both we are having integration of 1 divided by 1 plus. So generally we are taking, that is sine inverse x, integration of 1 divided by square root of 1 minus x square as sine inverse x plus c, and integration of 1 divided by 1 plus x square as tan inverse x plus c, and integration of 1 divided by x into square root of x square minus x as secant inverse x plus c. But required upon the requirement based upon the question, required based upon the questions. Suppose if we require 1 divided by square root of 1 minus x square as minus cosecant inverse, sorry, minus cos x, cos inverse of x means required upon the question, we are taking this one also. Suppose if to get an answer, if I get the integration of this one as minus cos inverse x means we are going to get an answer, or the answer it might be get simplified means at that time we are taking this one. And for this one, in case we are taking based upon the requirement, we are using this one also. So that is depending upon the requirement of the question, but in general I can say we are using integration of 1 divided by square root of 1 minus x square as sin inverse x only, and integration of 1 divided by 1 plus x square as tan inverse x only, and integration of 1 divided by x into square root of x square minus 1 as secant inverse x itself. The next is the differentiation of e power x is e power x is. So the integration of e power x with respect to x, we are going to get e power x plus c. Similarly, the differentiation of log of mod x is 1 by x. So clearly the integration of 1 by x dx, it is equal to log of mod x plus c. So clearly when I am explaining regarding the d by dx of differentiation of x to the power n plus 1 divided by n plus 1 is equal to x power n, so that the integration of x power n dx is equal to x power n plus 1 divided by n plus 1, where n is not equal to minus 1 I have mentioned. Suppose if n is equal to minus 1 means what happens here, this value minus 1 it becomes 0, so it will be going in that manner because this will become undefined. Suppose if n is equal to minus 1 means what happens, x to the power minus 1 dx. So x to the power minus 1 dx means what happens, 1 by x dx. So 1 by x dx means clearly we now itself we came across the integration of 1 by x dx is log of mod x plus c. So except at this point, for rest of all the integral values we are using this formula itself. For n is equal to minus 1, this formula we are going to get, that is nothing but the integral of 1 by x is equal to log of mod x plus c. So similarly we know the differentiation of a power x. So what is the differentiation of a power x? It was a power x into log a. So since when we talk about the integrals, I need only the integral of a power x dx means what I am going to do, since I need the differentiation, so the differentiating of certain factor I am going to get only this much means what I will do, I will differentiate. Since log a it is a constant, I will differentiate a power x with respect to divided by log a. So what happens, log a it is a constant, 1 by log a differentiation of a power x. So what is the differentiation of a power x? It is nothing but a power x into log a. Log a get cancels, we are going to get a power x. So what is the differentiation? That is differentiation of a power x divided by log a, we are going to get a power x. So similarly the integration of a power x dx, the integral of this one is a power x divided by log a plus c. So we needed this one. Suppose if I need the integral of a power x log a dx, if I need the integral of this one means how it goes, clearly log a it is a constant. So what happens, log a integral of a power x dx. So log a, what is the integral of a power x? It is a power x into log a plus c. So what happens now, if I multiply log a, here it get cancels, log a into c, it is again a constant, it becomes ax plus c. So the integral of ax log a dx will becomes ax plus c. So integral of ax dx becomes ax by log a plus c, and this one becomes like this. So these are the formulas, few of the formulas of the integral. So remember all these formulas. So because all these formulas are very important to calculate whole integrations like in the derivatives, all the formulas, how it was very important to find the derivatives. Similarly, in the integration, what and all formulas we have came across till now, all these formulas are very important. Go through each and every formula, understand the concept clearly, remembering that formulas are very important to solve the further questions. So that's all for the today's class, guys. If you have any doubts based upon the anything means, you can ask me at any time. Thank you.